Integration by substitution has another name called u-substitution. This is an extremely important and very popular technique in integration. When you take your higher level science and engineering courses that requires you to do integration, this is the technique that you will have to recall. So that means you might have to come back to this video in the future. So let me show you how to do integration by substitution. I usually just call this a u-substitution. Let's take a look at the first integral. So assuming you never learned this before, this is the only technique that works in this integral. So you have a rational function 3 minus e to the x divided by 3x minus e to the x dx, and then so let's say you only have a little bit of experience in integration. Do you have any technique to integrate this? I'm sure the answer is no, right? So this one must be done by a u-substitution. So what is the first step? The first step is you have to create another variable. That variable is called u, and you have to let u equals to something. So what is that something going to be? So that something is usually and if there is a radical sign, then the u must be the radicand. So something inside the square root or the radical sign. So in the next problem, I will just let u equals to x to the 4 plus 2. And then in the last problem, I will just let u equals to x plus 1. So something usually in the denominator or something inside a parenthesis. Something in, like for example, let's say you have a composition function. So you usually let the u be the inner function. So this one, I will just let u equals to 3x minus e to the x. So you let u equals to 3x minus e to the x, and then you have du, which is you take the derivative of that. So du is equals to 3 minus e to the x, right? So when you take the derivative of u, that is supposed to be du over dx, right? So let's put the dx on the other side. And then the last step is you will have to isolate the dx on one side. So we will just write 1 over 3 minus e to the x times du equals to dx. So another way to say this is we divide both sides by 3 minus e to the x. And then the next step is called change of variable. All right, so change of variable. How do we change of variable? We are trying to do substitution, right? Substitution means you have to plug in one piece into another piece. So the dx is equals to this, right? So the dx is equals to this piece. So what we are trying to substitute is we substitute this dx to this dx. So the integral becomes a du integral. All right, so let's go ahead and do that. And then the next step is you have an integral. So you have a 3 minus e to the x, and then the denominator is no longer the square root of that. The denominator becomes the square root of u because you let this radicand be u, right? And then the dx is multiplied 1 divided by 3 minus e to the x, and then a du, because you have a du over here. Okay, so can you do some cancellation? The cancellation is you get rid of the 3 minus e to the x, right? So that is equals to integral 1 over square root of u du, and that becomes the integral u to the negative 1/2 du. All right, so now this is much easier compared to what we have at the very beginning, and then you integrate that. So that, what is that equals to? This is a u negative 1/2 plus 1, so that is a positive 1/2, and then reciprocal is 2. So the reciprocal is 2, and then you add c to it. And then are we done? No, we are not done. I gave you an x, and then you end up with a u, so you have to put the x back to the u. So this is 2, and then if you don't want to keep the 1/2 power, just write the square root of 3x minus e to the x, and then plus c, and then this is the final answer to the first problem. All right, so the next problem is, what if we have a definite integral? How do we take care of the lower and the upper limit? Let's do that. So the next problem, we have integral x goes from 0 to 1. We usually don't write the x equals to, but I need to emphasize that the 0 and 1, they are what x equals to. And then you have ax to the 3rd power divided by x to the 4th plus 2, and then this is a dx. Now, you might ask me, hey, you just said that you let u equals to x to the 4 plus 2. Can we just let u equals to 8 times x to the third? The answer is you can try, but that is not going to work. So when you do u substitution, you need some experience to find out what u equals to, and you want to get it right in the first try. So this one, I let u equals to x to the 4 plus 2. Another reason to explain this is I am going to take the derivative, right? So when you take the derivative of x to the 4th, we are going to get a third power. So when we get a third power and then we go through the change of variable process, we have a good chance to get rid of the x to the third after the substitution. And then after the substitution, I need to remind you one more thing, that this is a du, right? So in the previous problem, this is du. That means I only want to see u in the integrand, but this we still have an x over here and then an x over here, but that is fine because we are going to get rid of them, and then we have a u only. So this is a du. You have to check your integrand, make sure there is no x. So once again, this is a du integral. You have to check your integrand to make sure there is no x. What if there is still an x or some x after the cancellation? Then your substitution is incorrect. So if you see some x in here after you have a du integral, that means your substitution is incorrect. So you have to go back to see what the problem is in that step. So you let u equals to x to the 4 plus 2, and then you have a du equals to 4x to the third, right? And then the derivative of 2 is equals to 0, and then you have a dx. You have 1 divided by 4x to the third du equals to dx. Okay, and then how about the 1 and the 0? The 1 and the 0 requires you to change them in terms of u as well. So you have to tell me what u of 1 is and u of 0 is. So basically you plug in x equals to 1 to the u. So that is 1 to the 4 plus 2, and then this is 0 to the 4th power plus 2. And then this is equals to 3, and then this is equals to 2. And then when you write your du integral, they are no longer x equals to 0 and 1. This is u equals to 2 and u equals to 3. You have ax to the third on top, and then the bottom is just a u only because you let u equals to that. And then the dx, so the dx, I'm going to do it right here. So we are going to plug in this dx over there to that dx. What is this step called? This step is called change of variable. Change of variable. You change the variable from x to a u. And then what is the dx equals to? So back to yellow. So we have a 1 divided by 4x to the third, and then you have a du. Do you see that the x will be gone? And then after you get rid of the x, we do not have any x left in the integrand, right? So you get rid of the x to the third, and then you have 3 to 2. And then you have 8 divided by 4 is 2. So you have a 2, 1 over u du. So 1 over u, the integral of that is ln absolute value, right? So this is 2 ln absolute value of u. U goes from 2 to 3. And then do we still have to go back to x? The answer is no. In a definite integral, you do not have to go back to x anymore. Just plug in the 3, plug in the 2, use the FTC, fundamental theorem of calculus, and then you are done. So this is a 2 ln 3 and then minus 2 ln 2. How come I got rid of the absolute value? Because 3 and 2, they are positive. This is one of the ways to write your final answer, but if you want to go a few steps further, you can factor out the 2. In my class, I let my students stop at that step. So, and then you have ln 3 minus ln 2. And then ln 3 minus ln 2 is the same thing as ln 3 divided by 2. This is one of the properties of ln. So if you do works and assignments online, they do not accept this, then you have to put your answer in this form. But in my class, especially when everything is handwritten, I accept this answer. All right, so the last problem, the blue problem, I said that problem has 2 hidden steps. So what are those 2 hidden steps? Let's get into that. So we have a definite integral. We have a x squared multiply the cube root of x plus 1 dx. So this one you are going to let x equals to, because u equals to x plus 1 because that is inside a radical. And then when you find the du, that creates a problem. So du, you only have a 1. So everything is gone. What do I mean by that? What do I mean by everything is gone? So when everything is gone, you have integral x squared and then multiply the cube root of u du dx. I mean, du. So this, you are stuck right here. You cannot proceed any further because this is a du integral. You still have an x squared. So how do you get rid of the x squared? So here is how. So you have u equals to that, and then you have to write those two hidden steps. The first step is x is equals to u minus 1, right? And then you have an x squared left right over here. So you will have to square both sides. X squared is equals to u minus 1 squared. These are the two hidden steps. And then you have integral, the x squared is now u minus 1 squared, and then the other one is u to the 1/3 and then du. And then you open up the square. After you open up the square, you have what? You have u squared minus 2u plus 1, right? And then times u to the 1/3 du. And then you distribute the 1/3. So you have a u2 plus 1/3. You add the power. So that is a 7/3. And then minus 2, 1 plus 1/3, that is a 4/3. And then the last one, let's make that look like a 3. So this is a 4/3. And then the last one is you plus u to the 1/3 and then a du. So now you can integrate this term by term. So this is a u 7/3 plus 1, that is a 10/3, right? And then this is a 3/10. And then plus u 4/3 plus 1, that is a 7/3. And then 3/7, so this is definitely a 7. 3 times 2 is equals to 6. When you take the derivative of that, you can get the 2 back. And then plus u, and then 1/3 plus 1, that is a 4/3. Reciprocal is 3/4. And then you plus c. Of course, this is not done. We have to put this back to x. We let u equals to x plus 1. So we have a 3/10. And then you have put the x back. So this is a x plus 1. And then 10/3 plus 6/7. X plus 1. 7/3. And then plus 3/4. This is a x plus 1. And then a 4/3. Don't forget to add the c at the end. And then this is your final answer. And then there is another way to write the 10/3. So this one you can put that as 3/10. And then the 3 you can use a radical. And then the x plus 1, you put an x plus 1. And then you raise that to the 10th power. I don't see a point of doing this because using a 10/3 is easier for me to check everyone's work. But if the online homework assignment system doesn't accept that, then you have to figure out another way to write it. Alright, so that is the end of this video. If you like the way I teach u-substitution, give me a thumbs up, a subscribe, and I will see you all in the next video for more u-substitution. Signing out.